The answer to the previous post is D. Filament. A bulb filament is a thin wire that glows when an electric current flows through it. This wire is the key part of an incandescent light bulb, producing light by heating up. Filament materials need special properties to handle high temperatures and provide bright, stable light. This article explores the history, characteristics, and uses of different filament materials, along with the pros and cons of incandescent bulbs. Properties of filament material. Good filament materials have high melting points, low vapor pressure, resistance to oxidation, high resistivity, and low thermal expansion. Types of filament materials. Common materials include carbon, tantalum, and tungsten, with tungsten being the most used today. Manufacturing processes. Filaments are made through processes like carbonization, powder metallurgy, and swagging to form thin, durable wires. Incandescent bulb drawbacks. Despite their warm light and easy manufacturing, incandescent bulbs are inefficient, short-lived, and produce excessive heat, leading to the adoption of alternatives like LED lamps. What are the properties of a good bulb filament material? The bulb filament material must have the following properties to function well as an incandescent light source. High melting point. The filament must be able to withstand temperatures of up to 2500 degrees Celsius without melting or breaking. Low vapor pressure. The filament must not evaporate or sublimate at high temperatures, which would cause the bulb to blacken and reduce its brightness and efficiency. Free from oxidation. The filament must not react with oxygen or other gases in the bulb at high temperatures, which would cause it to corrode or burn out. High resistivity. The filament must have a high electrical resistance, which means it opposes the flow of electric current. This causes it to heat up and emit light when a current passes through it. Low thermal coefficient of expansion. The filament must not expand or contract significantly when heated or cooled, which would cause it to deform or break. Low temperature coefficient of resistance. The filament must not change its resistance significantly when heated or cooled, which would affect its current and brightness. High Young's modulus and tensile strength. The filament must be able to withstand the mechanical stress caused by its own weight and vibration without sagging or snapping. Sufficient ductility. The filament must be able to be drawn into a very thin wire without breaking or cracking. Ability to be converted into a shape of filament. The filament must be able to be formed into a coil or a double coil, which increases its surface area and brightness without increasing its length or resistance. High fatigue resistance. The filament must be able to endure repeated heating and cooling cycles without weakening or failing.
Don't forget to follow us for more video.